Hello and welcome to R&B Mathematics. Today we are going to talk about solving exponential equations. Solving exponential equations. Now let's say if you had to find like 3x equal 9, this is a linear equation. What you need to do, you just have to divide by 3 both sides. You get x equal 3. But how about if you had 3 to the x equal 9? So something like that is actually an exponential equation because x is in the exponent. Now let's see some examples. Let's say 2 to the x minus 3 equals 32. How do we solve this? Well, in simple examples, so these examples, I would say they are simple examples. Simple examples, easy examples. In this case, what you need to do, well, 32 is 2 raised to 5. So 2 to the x minus 3 equals 2 raised to 5. Now one thing, exponential functions were one-to-one because the graph of the exponential function looks like this. And if you draw any horizontal line, see for each x value, you only get one particular y value, y value. So they are one-to-one. Because of that property at this step, one-to-oneness, that property, you can simply say this guy is same as this. So x minus 3 is going to be 5. So x is 8. So we are actually using one-to-one property of exponential functions. Now let's see a little bit more complicated, but still these examples also belongs under simple example category. Not that. Let me. How about this example? 1/2 raised to 4y equals 1/8. Now, how do you deal with this one? Well, can you write, it's a question, can you write 1/8 as a power of this guy? Yes, of course, that's 3, right? That's 1/2 cubed is 1/8. Because of that, again, using the same argument, 4y is going to be 3 and y equals 4/3. That's our solution. Now these are simple examples because the reason is the right hand side you can easily write it as a power of the required base. But what if you know, just think, instead of 32, what if you had 31? Then 2 to the x minus 3, 2 to the what? You cannot do that. Now that's why we need log. That's why we need log, and that's one reason why we learned log. Now let's see an example of that form. How about this? 3e to the 2x minus 2 equals 7. Now the first thing you need to do, isolate the term with exponential term. So in order to do that, I will add 2 to both sides. Then I'll get 3e to the 2x equal 9. And when I divide both sides by 3, I get e to the 2x equal 3, right? Now at this step, I cannot write 3 as a power of some power, so it becomes e to the 2x. So it's not easy, it cannot be done. So what you need to do at this step, remember guys, this is the most important thing. At this step, take log of same base each side. So in this case, what you need to do, take, in this case, log base e, or which is same as ln. So I'm going to take ln of both sides, e to the 2x. The reason why you do it ln and log and that base, they will cancel, and this is simply 2x. That those were some properties we were talking about. So x is 1/2 ln 3, that is the simple as that, that is the answer. Now, as let me go to the previous page. Look at this example. Let's make it 31 and see, as I told you, 31. So 2 to the x minus 3 equals 31. In this case, what you need to do, take log base 2. Why? Because here the base is 2. Once I do that, log and exponential base, that will cancel. You only will have x minus 3. So log base 2 31. So log base 2 31. So x is, when I add 3 to both sides, 3 plus log base 2 31. And after that, either you need a calculator or logarithmic table to find the final solution. Now, what if, let me go back and let me ask you this question. Now, in this simple example, those examples that I classified as simple, can't you take log of both sides? Of course you can, right? Let's just take this one. What if I take log of both sides? Log base 2, 2 to the x minus 3, log base 2, 32. Now what will happen here is, similarly, this whole term is just x minus 3 because log and exponential will cancel. And here log base 2, 32. That is just 5, see? Oh, if you can't, 2 to the 5 is 32, and when you convert this into exponential form, this is log base 2, 32 equals 5, see? So that is 5, it still works. But when the right hand side, or when the other term can be easily transformed, you don't need to do that. For example, let's say you had 5 to the, another example for this, let's say 5 to the 7 minus x equal 125. Now in this one, yes, at this step you can take log, right? First of all, if you have more terms, you have to isolate the variable. Let's say instead of this, let's say you had minus 5 equal 120. In this case, what you need to do, add 5. That's the first step. So add 5, isolate that term, you get 125. And at this step, if you can write down this guy as 5 raised to something, which is, yes, you can 5 to the third, 5 into 5, 25, 25 into 5, 125. If you can do that, yes, go ahead and do that, because then it's really easy. Using one-to-one property, 7 minus x must be 3. So x is going to be, when you take x to the other side, x is going to be 4, right? But if you want at this step, again, you can take log. If I do that, log base 5, 5 to the 7 minus x equal log base 5, 125, which turns out to be again 3, and you will end up having the same result. And how about this? Let's do one more example. How about this? Little bit complicated example. E to the x squared equals 16. Can you solve this? Well, in this case, only thing you can do, take ln of both sides, because ln and e will cancel. This term becomes just x squared, then and ln 16. And so ln 16, that's pretty much it, but we are not done yet. You have to solve. So x is going to be plus or minus square root of ln 16. Whatever ln 16 is, plus or minus square root, that will work, because this, at this point, this is a quadratic equation, right? Okay, I think how about this, another nice example. And after this example, I'll stop this video. So how about this one? Now, in this case, this is little challenging, right? Because it does not belong to any of those examples that we did earlier. We can do a simple trick. And I mean, how do you do these kind of tricks? Well, that's by experience. Now, if you observe carefully, here we have 10 to the x, and here we have 100 to the x. 100 to the x, see the number 100 is actually 10 raised to 2, right? You can write it like that. So 100 replaced by 10 raised to 2 and then x minus 10x minus 2 equals 0. So 10 to the 2x minus 10 to the x minus 2 equals 0. Now it's really nice. Why? Because we can convert this, but still it's a little bit of confusion. I mean, because you cannot do at this point. See, common mistake is people may write 10 to the 2x and here minus and minus x. No, it's not correct. You cannot deal with powers like that. So at this step, only thing you can do, let's say, pause the video and see whether you can try this. Okay, a substitution, a nice substitution is there. So can you now guess? U equal 10 to the x. When I do that, look at what will happen to u squared. What is u squared? U squared is 10 to the x squared, which is same as 10 to the 2x, right? Because this means 10 to the x squared means twice that term and powers get added. So that's why 2x. So this term is u squared minus this term is u, because that was our substitution, minus 2. Now this is a nice quadratic equation. I can see factors u2 and 1. I need minus, so minus and plus. So my u is going to be either -1 or u is going to be 2. If u is -1, 10 to the x is -1, or if u is 2, 10 to the x is 2. Now at this point, so let me go to the next page. So 10 to the x is -1, 10 to the x is 2. So 10 to the x is -1 and 10 to the x is 2. That's what we had. But if you take log, see the base is 10 now, so you just have to take log of both sides, log 10x, log of -1. And this is impossible because log has to be here positive. So in this root, we don't have any solution. But from here, when I take log, x equal log 2, and that is our final solution. Okay guys, that's enough examples for today's video. Thank you.